Hi guys! In this video we're going to go over section 2.3 and it's going to be on linear functions. We're going to look at slope, graphs, and some linear models. So in the last section we looked at functions, and in this section we're putting particular focus on linear functions. So let's begin by looking at two different linear functions. So just to say first, a linear function can usually be written in the form y equals mx plus b. Or actually, yeah, any linear function can be written in this form. So notice that each of these functions are in this form. Here m is 2 in both of these cases, and b in this case, even though there's nothing there, that just means b is 0. So I'll note that this is the same as 2x plus 0, so b is 0 here. And then b is 1 here. So yeah, without going too much into what this is called the slope-intercept form, by the way. But without going too much into the details of slope-intercept form, what I'd like to do is just try to plot both of these lines. The lines y equals 2x and the line y equals 2x plus 1. So we're going to plot those two lines by just creating this table of values, and we're going to fill in various values of x and then see what we get for y on the other side. So for the values of x, you can almost choose whatever you want. You want to choose some reasonable values, something that'll give you some idea of what the picture looks like. So you want to choose values that are somewhat close together. So I'll say we'll do -2 through +2. So I'll do -2, -1, 0, 1, and 2. So these are my inputs that I'm going to send through my function and see what I get on the other side. So say I plug in -2 into the first function. This would be the same as 2 times -2, right? 2 times -2 is -4. So we plug it into the first function, we get -4. And now let's look at what the other function does. The other function is 2x, but then afterward it adds 1 to it. So if we plug in -2, again we get -4, but then you have to add 1 to -4. So after adding 1, we get -3. Now notice, we don't really have to calculate this column. We can just calculate this column and then add 1 to each of the things in this column. Let me show you what I mean. So if I plug in -1, we have 2 times -1, that's -2. So we have -2. And for this column, we're just going to add 1 to this number. So we take this number, add 1 to it, we get -1. Again, 2 times 0 is 0. We add 1 to it, we get 1. 2 times 1 is 2. And then 2 times 1 plus 1, again, it's just adding 1 to this, we get 3. And 2 times 2 is 4, so then for this column we get 5. Now what I want to do is I want to take both of these lines and I want to plot them below on this coordinate axis here. So I got a little bit lazy just for the sake of how the picture looks, and I only wrote a 1 here, and say I'll write a 1 here as well. But I just want to mean that each of these tick marks is spaced out by a distance of 1. So this is 1, 2, 3, 4, 5. This is -1, -2, -3, etc. And then this is 1, 2, 3, 4, 5. So these are counting by 1. These tick marks, you can say the scaling is by 1. But anyway, that's how the tick marks are spaced out. So we're going to plot these. So I'll begin by just doing the first line, y equals 2x. So I need to plot the point -2, -4. So -2 is here, and then I go down 1, 2, 3, 4. This is -2, -4 down here. And I'm going to plot another point, -1, -2, 0, 0. I should have done this let me do this in a different color actually. Let me do this in blue. So we've got -2, -4. We've got -1, -2. We've got 0, 0. We've got 1, 2, so 1, 2, we go over to 1, we go up 2, we've got 2 comma 4. That means we go out to 2 here on the x value, then we go up 4 to here. So now connecting these points gives us a line. And if we want to be smart about this, what we want to do is we want to take this and use the fact to plot this line. We're just going to use the fact that here we've got a +1 that's additional, that wasn't here, right? We have that +1 here. So simply what we're going to do is just imagine this other line right here as this line. It's the same exact line, except it's shifted up 1. And here's what I mean. Every single point that we plotted on this line is now 2 units higher than it was. Or sorry, I misspoke. Every point on this line is 1 unit higher than it was. So we see we have -4, -3. So notice -4, or sorry, oh gosh, I'm stumbling over myself. I'm so sorry, guys. What I mean is that -2, -3 would be the next point, because that's the x value and the y value for the other line. So -2, -3 is down here. It's shifted up 1, so it's like right there. And then the next point would be -1, -1, which is like right here. Notice it's not touching this line yet if I draw a line through these 2 points. The next point is 0, 1, which is up here. And then the next point after that is 1, 3. And then the next point after that is 2, 5. So notice if I draw in this line now, supposing I did this perfectly anyway, these are called parallel lines. These lines right here, these 2 lines, these are parallel lines. They do not intersect, is what that really means. So 2 lines, they do not intersect. So that's what it means in 2 dimensions. These are equivalent. So yeah, this is the graph of y equals 2x here, and y equals 2x plus 1 above it, because we shifted the graph of y equals 2x up 1 unit. And notice the reason why they're parallel lines is because they both have the same slope of 2. So they both have the same slope, but they have a different, what's called a different y-intercept. The y-intercept of a graph, y-intercept. The y-intercept of a graph is where the graph crosses the y-axis. So in this case, we can think of as y equals 2x as y equals 2x plus 0. So 0 is your y-intercept for this function, and 1 is the y-intercept for this function. So pretty much, we've plotted both of these lines. We can see that they're parallel, they don't intersect, and we see that they have different y-intercepts. But now that we've done it with a table, in the next video we're going to take it a little bit more systematically. We're gonna exploit this slope-intercept form. We're going to exploit the slope-intercept form up here above, y equals mx plus b, and we're going to use it to plot lines much more quickly than this process, right? Because this video was somewhat long. I did have to explain every step along the way, but if we use the slope-intercept form instead up here, we can actually plot lines much quicker, and that's what we're going to do in the next video. So if you made it through this one, good job. In the next video, we're going to graph a couple of lines much more quickly, and I'll show you how.